Hi, and welcome to Simple Data Science. Let's understand MLOps through FAQ. First question that anyone can ask me is, why MLOps and how is it like to work in a project without MLOps? So MLOps is not really the cookie cutter in a project. However, it is mostly recommended. The reason being, if you do not have the right set of processes and a system in place, when you are working on a data project, you are delivering machine learning models and deploying them into production, you have an issue or you have an additional feature that you want to bring into the system, you don't want anything else to be breaking down because you added a small piece of code in there. So having MLOps will help you run the tests on its own, deploy the code. A lot of these processes are automated for you, so you are less likely to make any mistakes. And it is also faster to deliver products and models to production in a faster way. Okay, let's understand why MLOps. Why do we actually need it? So, as I mentioned, it is to speed up the process of model building and also productionizing it. So, during productionization, you have a lot of problems like scaling, reliability, security. In an enterprise level, if you're trying to productionize models, you face all these challenges. So, most of these challenges are addressed by MLOps with the set of processes that it brings in. The process of deploying models into a production server. So you can automate this process. You can automate this process by just click of a button. If you can deploy the model that you have validated and it's performing the best, you have chosen your best performing model and you want to deploy it. So with a single click of a button, you can deploy models to production. As simple as that. Because MLOps has these tools, and we will talk about those tools in upcoming slides. As I mentioned, MLOps will help you achieve the scale, reliability, and it becomes very easy to continuously improve your models and put them on production. So these are the features that the industry is looking forward to and the enterprises are looking forward to, because the business dynamics are changing and your requirements are changing, the data is changing, people who use products are changing. So when you have these requirements changing in a rapid manner, you have to adapt to it. And when you don't have proper processes and setup to bring that agility into your data project, it becomes a little difficult to bring out those number of good features into production and also monitor their performance in real time. All this becomes very challenging without MLOps. When I say monitoring, once the model is into production, we can't call the job as done because it needs continuous monitoring. Like I said, the data can change, people's behavior can change, your competitors can change, and a lot of dynamics are involved. So you want to make sure that your model in production is up to date and is able to capture the patterns in the new real-time data that is coming in. So model monitoring is very important in that aspect. And another set of process that really helps in managing your data science project is the version control. With MLOps, you can control your data version. You can version control the experiments. You can actually versionize your experiment that you have performed, the data that you have been using. You have added any new features or new set of data you have brought in after you do all the VDA and troubleshooting, debugging. So you can version your data. So when you have this process, and also you can version your models. So when you do this versioning, the way it helps is, say in some point of time, the model starts breaking in production. It's not giving the accuracy or the metric that you were looking for. So you can understand how the data has changed in your newer versions when you have this version control in place. So you can compare your existing data with your old data that you had trained your model on. So you can also understand if you have a feature store where multiple teams are working on a similar data set and adding features to the set. When you have version control data and something breaks, it will be easy to track back to understand what kind of feature was brought in and when the problem started showing up, and things like that. Okay, what kind of tools do we have and processes for MLOps? So MLOps basically derives most of its practices from the methodology called DevOps, developer operations. So all the processes and tools that are applicable for DevOps is still applicable here. However, we have a few more additions, like you have model training and you have the data versioning, data things like that. Because DevOps is usually for software development practices, but when you have the data science thing, the machine learning thing, it not just software building, but you also have these extra things like model training, the data you're coming, because in normal software projects you don't use much of data, and also you don't have anything like model training and things like that. So MLOps is basically DevOps, but little enhanced features are available in MLOps because it requires it. So the first component I would say is continuous integration. Continuous integration is when you have your code base, it's a framework to work in your project, and when you have implemented continuous integration, what happens is when you add a new feature or you debug something and you fixed it, the changes that you have made should not affect any other part of your project. So what you need to do is write tests accordingly, and when you are done with your code changes, continuous integration will run the unit tests or any integration tests, and it will give you a result as to ensure that your brought in changes have not made any impact on your existing functionality or existing parts of your other project, So to achieve this, we can use some tools like GitHub Actions. You can use Jenkins, Circle CI, basically any CI/CD tool, GoCD, Travis, and so on. So continuous delivery, most of the tools are built in such a way that they can do this continuous integration thing wherein it can test your software and also do the deployment part, automated. So continuous delivery is the deployment part of the code. And most of the same tools, GitHub Actions, Jenkins, Circle CI will help you in continuous delivery as well. Okay, another thing is APIs for model consumption. So you have your model ready, and you wanna somehow expose it to an end user, like an application which will call the APIs or your model. So one way is to expose these models as REST APIs, and you make HTTP calls over internet, and then by just sending a payload, you can get back your results and you can use them. Another way is batch processing, where you just have your model and once in a while you schedule a job saying you feed in the data to the model and you get the predictions. So not necessarily you have to have a REST API every time, but MLOps will recommend you this option because this is scalable. APIs are scalable. Yeah. So for these, you have some tools like Fast API, Flask. If you are using some tools called like MLflow, you have an inbuilt serving mechanism where an STM point is created with just a command run like that. So another part is infrastructure as code. Like I mentioned, MLOps targets scaling. The moment you develop a model, you can make it available to hundreds or thousands of users at the same time. That's scalability. And to make that possible, you need this component, infrastructure as code. Like what kind of environment is your model going to get deployed in. Yeah. If you can bundle this infrastructure as code, what is the compute specifications? How many cores it has to have? What is the dependencies it has to have? Uh, what what sort of capabilities? What sort of libraries? All that you want to have in the environment that your model runs on. If you can package everything as a code, like mostly these IFE, or you will have it in config files, YAML files, and if you're using Dockerfile, Makefile, multiple things. So if you can codify this part into your data science project, that is going to give you a long way into your data science journey. And let's understand who implements MLOps in the team. Is it ML engineers? Is it data engineers? Is it site reliability engineers, data analysts? Who? Actually, MLOps implementation involves setting up certain processes and systems, installing softwares, configuring infrastructure, cloud, all that. It is an investment you are doing for your own future of your data science project. So you will not have issues in the future. So when you have a beautiful system set up, it becomes really easy to address issues, troubleshoot issues, bring in new features, adapt to the changing business environment, etc. So anyone in the team, data science project team, data engineers, ML engineers, SRE, data analysts, everyone can contribute to this system in setting up MLOps for your project. Most often question I get asked is, do I need a cloud to implement MLOps? Well, the answer is no and yes, both. The reason is without cloud offerings, you can still implement MLOps. There are multiple open source softwares. You have Git, you have MLflow, you have other open source softwares like DVC, data version control, CML, continuous machine learning, which DAGs Hub offers. So there are a lot of open source projects out there. You can implement it even in your on-prem server, but you have to put in your extra effort to orchestrate all these components, put together these things, and make them work. This is going to take your time and effort. So what cloud does is, cloud already has all these offerings to you set up for you, and most of the times within a few clicks here and there, just specify what you need, where your data is, where the models are, and it'll bring your things together, and it'll start serving your model, and also helps you in scaling. Cloud offerings have all these features inbuilt into their platform, so it becomes very, very easy to manage your project in a very small amount of time. What skills are required for MLOps? Well, this is the hardest part. And it's not easy to get people who are skilled in MLOps, because it takes a lot of skills for an MLOps engineer. You need to have Linux experience, Bash command line experience. You need to have Git experience. You need to have some kind of unit testing framework like PyTest. You have to know MLflow library or similar libraries which will help you in tracking your models, tracking your data, tracking experiments, the package which can offer you these things. So this is also hard, because not everyone is used to it. This is an emerging field. It's been there actively in mostly 3 years, and not many of them are trying to do that. Okay, and you need to know about containers, because containers are sandboxes where you can build your environment, where you're gonna deploy your models, and you can spin up as many as you want based on your concurrent users and things like that. So you need to understand about containers, Dockerization, everything. But some of these components will be simplified if you are using cloud. For example, in Azure, if you want to deploy your model into a Kubernetes cluster, you can do it within a few clicks and selecting few options from a few drop downs. But if you have to do it on your own, then it's gonna take a lot of time, effort, and you need to know a lot of it, lot of containerization background and things like that. So that's one part. So infrastructure orchestration. Yeah, if you do not have cloud, then you will most likely do are expected to understand a lot of infrastructure orchestration, how multiple systems connect together, work together, and how the data flows, how the models are working, how models are deployed, how the inference is happening, tracking everything, putting all these components together and making it work requires a lot of infrastructure orchestration experience. Okay, what are some of the components in an ML ops project? These things we have touched upon already. Uh, so a cloud platform, although I have told you that platform is not necessary, but forward thinking, you need a cloud. You need a cloud because most of the companies are embracing cloud because they can bring out your softwares out there into the market pretty quickly. So you have Azure, AWS, GCP, and there is one more portal called as TaxHub. It's a startup. You can do a lot of projects. It has a lot of support for open source tools, and there's a lot of popular data science projects running on TaxHub. Definitely check that out. So you need a continuous integration tool. I can have Actions, Jenkins, CML. I think CML is from iterative.ai. And continuous delivery is mostly built into this continuous integration tool. So again, so you need data and model version control systems, which is DVC, data version control, again by iterative.ai, MLflow, and open source software used for this. And you need APIs and API building packages, and you need infrastructure as code. Okay, so do let me know what is your favorite set of tools that you have used in your data science projects. I would love to hear that. And if you have not subscribed to my channel, Simple Data Science, hit the subscribe button and let me know what you want to see next on Simple Data Science channel, particularly on MLOps. Thank you.